Welcome students. So today we shall discuss about online practicals. In that, second experiment is dispersive power of prism. Of course, this is the experiment from group B. Okay. So name of the experiment is dispersive power of prism. We have discussed about angle of prism, how to calculate angle of prism, etc. Now here dispersive power, that is power of dispersion. Okay, that the dispersive power of prism. We have learned power of dispersion or dispersive power and the relation of dispersive power in the optics paper second. Okay, so here we shall discuss about dispersive power of prism in this experiment. Okay, so aim of the experiment is to determine dispersive power of prism. Apparatus needed for this experiment are spectrometer, level bottle, mercury source, prism, etc. You know very well that mercury source is a polychromatic source, that is which has 7 colors. Okay, so according to our first experiment, that is a least count of instruments, we can calculate the least count of spectrometer, which is nothing but the ratio of smallest division on main scale divided by total number of divisions on vernier scale. So which is equal to 0.5 degrees upon 30, which is equal to 30 minute upon 30. So here we can convert 0.5 degrees into minutes. So 30 minutes upon 30 is equal to 1 minute. Okay. So this is the ray diagram of the experiment, that is dispersive power of prism. So here triangle is visible to you. A, B, C stands for a triangle. The triangle is nothing but the prism. And generally B to C is the base of the prism. That is generally we used to denote base of the prism along BC. Okay. So at the left hand side of this prism we have an incident ray. Okay, of course, which is the white light, white ray. Okay, it is difficult to denote white color because this screen is white in color, therefore I have denoted it by black color, and which is incident on the edge of the prism over here. Okay, and when this white light is traveling through the prism and which is emergent outside the prism on the same medium, that is air medium, that path we have denoted through the dotted line. This path is there. Suppose if prism is absent, then this incident ray would continue the journey over here, but due to presence of prism we can observe separation of white light into its constituent colors. Okay, so we are concerning about dispersive power of prism, hence we need only red, yellow and violet colors. Okay, so suppose we observe red color or red line, then yellow color or yellow line, then violet color or violet line, then we can find out the angle of minimum deviation for red color, which is the angle between the dotted line, that is the original path of incident ray, and the red color. Then delta y is the angle between original path of incident ray and the yellow color, and then delta v is the angle between original path of incident ray and the violet color. So this delta r, delta y, delta v for red, yellow and violet color respectively, we can measure through spectrometer. Okay, so we need to understand the least count and how to measure the angle of minimum deviation for red, yellow and violet color respectively. Okay, so this is the formula to find out least count of the spectrometer. So as I told you in the angle of prism experiment, to convert the obtained minutes into degrees, divide the minutes by 60. Okay, so this is the diagram, or what we can say photograph, actual photograph of the white light separating into its constituent colors through prism. Okay, so here is the white light at LHS white ray, and here is the spectrum. Okay, so after that, you know very well that light has wave nature. Okay, so here is the incident white light. This is prism. This is prism. This is incident ray. Therefore, I shall write here IR, that is incident ray. This is prism, and this is red color, that is denoted through waves. Then orange color, then yellow, green, blue, indigo, and violet. Okay, so 7 colors are visible on this animation. So this is the dispersive power of the prism. That power we have to calculate with the help of this experiment. So moving on, so this is the spectrometer, and you have to hold the prism on the prism table or turntable, and below that we know very well two windows are there through which we can obtain the readings. So this is slit, this is collimator, this is P, that is prism, this is prism table, therefore I shall write here PT, and this is the telescope, and this is eyepiece. So E stands for eyepiece. So through eyepiece, through this small hole, if we place our eye, we can observe this circle stands for this eyepiece, and inside the eyepiece we can observe spectrum like this. Okay, so this is from red to violet color. That is red, first one. If I start from left hand side, first one is the red, then orange, then yellow, then green, then blue, then indigo, and violet. So VIBGYOR or ROYGBIV, such type of colors are observable through the telescope and through the eyepiece. Okay, so this line spectrum you have to observe, and you have to take readings for red color, then for yellow color as mean color, and the last one for violet color. So with 3 readings, and after that with direct reading we can find out the dispersive power, that is omega, of the prism. Okay, so this is broad view or magnified view of the spectrum which is observed through telescope. Okay, so this is more clear that first one is the red color, then second one is the orange color. If I start from red or LHS, red, orange, then yellow, then green color, then blue color, then indigo color, and then violet color. So VIBGYOR or ROYGBIV. Okay, so after that observation table is there. In that observation table you have to take spectrometer reading for red color, for violet color, and for yellow color, and for violet color. Okay, so here suppose this is red color, and you are observing it through the eyepiece. So suppose this is the cross wire, and adjust the red color on the cross wire, and then observe the reading on the spectrometer through this window. Okay, through this window, so that you can have the reading for red color, then for yellow color, then for violet color. And after that, what about direct reading? Yes, direct reading can be taken with the help of this diagram. You can understand the direct reading with the help of this diagram. So here is the direct reading. Okay, so in case of observation of direct reading, that is DR, you have to find out the slit reading or the incident reading of incident ray. For that, you have to remove the prism, and now you will observe that the incident ray, that is slit, is visible, and then that slit is nothing but the direct reading. So write the direct reading here, and then take the difference of this direct reading and red color, write the difference over here. Then take the difference of this direct reading and yellow color, write the difference over here. Then take the difference of direct reading and violet color, write down the difference over here. Now using this prism formula, that is mu is equal to sine inside the bracket a plus delta m divided by 2 bracket complete divided by sine a by 2. Now sine the value of a is 60 degree. Okay, so for a, write over here, for a is equal to 60 degree, and delta m is this value. Okay, so this is delta m. So you have to calculate refractive index for red color. So this is delta m for R. This is delta m for yellow color, and the last one, that is delta m for violet color. So after calculation, this is refractive index for red color, then next one refractive index for yellow color, and the last one is the refractive index for violet color. Now you will use the formula, that is omega is equal to mu v minus mu r divided by mu y minus 1. Now here is the mu r, substitute the value of mu r over here. Then here is mu v, then substitute value of mu v over here. Then mu y, the mean color, substitute the value of mu y over here, and taking the ratio, you will calculate omega, that is dispersive power. So with the help of this mu refractive index, we can calculate the dispersive power of prism. So this is all about dispersive power of prism experiment.